So we're still in section 1.8 and now we're going to take a look at nonlinear inequalities. So these require typically a little bit more work or just kind of a little bit more thought. Notice that there is a text box here that gives us kind of how to look at this, how to get our answers. So what we have first is a quadratic inequality. And the issue with this is we can't just isolate the x and in the same way that we can with the linear. So what we have to do instead is we have to think about finding the values where the inequality is equal to the value that you see on the right-hand side. So in this case, 0, and then use those values to then think about what's happening on either side of those, any of those values. So for something that's quadratic, typically I would bring everything to one side and notice that it does have 0 on one side. So the first thing I would do, I would think about the equation, x squared plus 2x minus 3. In the text box, it talks about the critical value method. That's what's happening here. We're trying to find the critical values first. Critical meaning important. Because of all the work we've done with quadratics, the first thing I'm going to do is try and factor this. So you can go ahead and try that. See, not too much happening here with that 3 and with the coefficient of the x squared term being 1. But it does in fact give us x equals 1, x equals negative 3. Then I can put those onto here. So x equals negative 3. So the idea is now I'm going to create a number line. So I'm going to put these two values onto my number line, negative 3 and 1. And then what I want to see is on either side of these numbers, is my inequality true or false? And if it's true, then it's part of my solution. And if it's false, it's not part of my solution. So the way I would think about it is I'm going to now combine the two things that I just kind of thought about there. And I'm going to write the factored form, but with my inequality. Okay. Then what I'm going to do is I'm going to pick any value at all that is less than negative 3. Anything will work. A lot of students, if I say pick something less than negative 3, they say negative 4. It's the first thing they think. But really, any value will work. So for example, we could choose, so now we're going to test some values here. And sure, let's pick x equals negative 4. So I'm going to put that into this inequality, and I'm going to see what happens, true or false. So if I put in negative 4, notice that the first binomial becomes a negative 5. The second binomial becomes a negative 1, and I'm testing to see, is that greater than or equal to 0? I get 5. 5 greater than or equal to 0? Yes, it is. So that means that for the interval, negative infinity, all the way up, because this is a number line that's going from left to right, negative infinity all the way up to negative 3, I have something that is true. So that means it's part of my solution. And because negative 3 makes it 0, and we have greater than or equal to 0, I can put a bracket there, the square bracket. Now I'm going to pick something between negative 3 and positive 1. It's very common to use 0 whenever you can. That is within negative 3 and 1, so I'm going to use 0. When I plug that in, I get negative 1, because 0 minus 1 is negative 1. And I get 0 plus 3, which is 3. And I'm testing to see, is that greater than or equal to 0? And we get negative 3 greater than or equal to 0, and that is a big fat no. So because of that, this interval is false and it's not part of our solution. Then we take a look at anything greater than 1. So of course, many options here, but if you are saying, I just want to do 2, that is okay. We put that in, 2 minus 1 is 1, 2 plus 3 is 5, greater than or equal to 0, we get 5 greater than or equal to 0, and of course that is a yes. So we have another true interval. And so that means that 1 we know works, all the way up to 3, all the way up to infinity, and we're not going to include infinity. So both of these intervals on the number line contain all the values that if you plug them into that original inequality, you're going to make that inequality true, and therefore they are part of our solution. I can then put a union in between them. You may want to make a note if you haven't seen that. That is union. It just means that because I have two intervals, I'm going to union them together with this. This is a set notation thing. So typically anytime we have multiple intervals that are part of a solution, we combine them using the union symbol. All right, so it's kind of like there's 1, there's 2, and then there's 3. That's kind of our third step there, is testing everything. And then of course, we have our solution over on the left-hand side. Okay. Now give the solution in interval and set notation. So notice this is similar, except it is rational, so it's not quadratic. We still have everything less than or equal to 0, so that's good, but we do need to find any of our critical values. So notice from the text box that we want to think about anything that would make this inequality equal to 0 or undefined. So for most students, it's pretty easy for them to see, okay, look, x cannot be equal to 2. If x is equal to 2, I get 3 in my numerator, I get 0 in my denominator. That is not a number. You cannot divide by 0. Therefore, we cannot have 2. But we might be able to have something greater than 2, less than 2. So because of that, 2 becomes a critical number. So that's our first one. If you have a fraction on the left-hand side, less than or equal to 0, the only time that it can be equal to 0 is when the numerator is equal to 0. So we set the numerator equal to 0, and we find that x being -1 is another critical value. It's another value that we need to be thinking about in terms of what's happening on either side. So I'm going to put my 2 values here, and I'm going to check them. Now, we remember already, like 2 is not a possibility, so it cannot be part of our solution. It makes it false. -1, if we plug it in, notice we get 0 divided by -3. That is 0, and 0 is less than or equal to 0. So -1 is part of our solution. So I'm going to do this one in a slightly different way. The last one, I tested points. I'm still going to do that, but you can also do it on a more table, if you like a table. That's fine. So here's a table if you'd like to use that. Again, we're just looking at these 3 intervals that we have here. So we want anytime x is less than -1, we choose a value. What do I choose here? I get crazy. I choose x equals -5. I plug it into the numerator, I get -4. I plug it into the denominator, I get -7. The question is that less than or equal to 0? And of course that is 4/7, which is not less than or equal to 0 because that's a positive number. So that is false. So that tells us that that interval is false, not part of our solution. Then we want to pick something between -1 and 2. So common guess there would be putting in 0. Common test would be 0. Numerator is 1. Denominator is -2 if we plug in 0. And we can see that, yes, -1/2 is in fact less than or equal to 0. So that is going to be a true interval. And then anything greater than 2, so x is greater than 2. And we check something there. So I'll get real crazy. I'll put in 10. Our numerator is 11. Our denominator is 8. And asking if that's less than or equal to 0, we can pretty easily see that that is not true because it is positive, so it's definitely not less than or equal to 0. And so that's another false interval. So that tells us that it is only this interval that makes it true, which is going to be when x is greater than 1, but notice we also have that -1, x is greater than -1. -1 makes it true. We already can see that if we plug in -1, we are true. And so we want to include -1 all the way up to 2, but we know we can't include 2 because 2 makes the whole left side undefined. So anything, however, up to 2 would work, like 1.999999999. And so that's why we put the 2 there with the parentheses. The 2 is like our limit. Can't go any further than that, and can't include 2. Okay, now we have another very exciting one. So this one is actually of like degree 4 here. It's got quadratic, first piece, then we've got a couple linear binomials here. So this is a polynomial on the left-hand side, but it's already in factored form, which actually works out really well for us. So because this is already in factored form, and because the first thing we want to do is think about when is this equal to 0, that's going to tell us x squared equals 0, x plus 2 equals 0, x minus 3 equals 0, and that gives us some values that we need for our number line. So what I would really like you to do, if you could, was take a moment, well, maybe a couple moments here, and either use kind of the first method where you're just picking some test points and just putting that right onto the number line, or kind of the second method. They're very, very similar, but using the table, whichever thing you like to do. Take a moment, see if you can do that. Go ahead and pause that and then bring it back and we will talk about it. Okay. So notice, very important, I'm putting these numbers on the number line in order from smallest to largest. Because of this greater than, we never want to be equal to 0. So even though we found these values, they all make our situation false. False. Right? There's none of them can be included because they all make it 0. They don't make it greater than 0. So now what we need to do is think about what happens if we plug in some test values. And you do get faster with this, I promise. So if we pick something that is less than -2, so I'm going to do kind of the first method here, pick some values. So something less than -2, I'm going to say like -10. One thing that you can do, because the right side is greater than 0, I just need to know, is my value positive or negative? I don't even need to know what happens when I plug in -10. I just need to know, is the number going to be positive? Is the number going to be negative? So if you think about plugging in -10, if you take -10 and you square it, that is a positive number. If I plug in -10 plus 2, that's a -8, so that's negative. And then if I do -10 minus 3, that's a -13. So that's negative as well. So now this is the question. Is a positive times a negative greater than 0? Negative times positive times a negative is negative, times another negative is positive. So is a positive greater than 0? And we say yes. So that gives us a true interval. And then we can do the rest of them that way. Again, you can pick values, you can actually find the number, but it doesn't really matter what the number is. What just matters is it makes the inequality true, and all that matters there is whether it's positive or negative. So if I pick something between -2 and 0, I can't pick 0 this time around, but say I pick x equals -1, I'm going to have a positive 1, so I'm just plugging this into all my factors over there. And I'm remembering that I'm trying to show you how to do this without having to focus so much on all the actual values. So if I plug in a -1, I'm going to have positive times a positive times a negative. And being greater than 0, you can see, I keep doing this. Okay, I don't care about what it is. It's not that number anyway. It's just a negative. It's just a negative. We don't have to write -1. It's just a negative. Okay, here we go. So a positive times a positive is positive, but times a negative is a negative. So a negative is not greater than 0. Nope. And so we have false. Then we can keep going, picking something between 0 and 3. Maybe I pick 1. And so I'll have 1 squared times 3. Gosh, I keep trying. I keep doing that. I'm just used to it. But again, it gets faster if you don't think about it that way. Okay, let's see. Okay, so x being 1, we're going to have positive times a positive times a negative. Okay, and that is not greater than 0. We already just saw that, so that's another false. And then we pick something greater than 3, like 4. And when we plug that in, we get positive times a positive times a positive, and that will be greater than 0. So because of that, we can then say yes, and now we have another interval that is true. So we can see that our first true interval is, now that I've got quite a bit happening on my slide here, but we have, these are the values that we care about. These are the values that will be in our solution here. Okay, so coming all the way up to -2 from -infinity is our first interval. Then we don't have anything in between that because the interval is false all the way up until 3. And 3 is not included, but we can go all the way up to infinity after that and close everything up with parentheses here. So notice it's all parentheses, partly because there's no equal sign in what we have in our original inequality, and also because we don't have, we are dealing with infinity, and anytime you're dealing with infinity, you're going to have parentheses as well. But that is the answer to that. If you did the table, that's no problem. That's a great practice as well. Whichever way you like to do it is fine and gives you the same answer that we got here. So that's a couple more examples.